Hi there, in this video we're going to look at collinear lines, and we're also going to look at how we can write the gradient of a line as the tangent of an angle. Okay, so if we were to draw out two lines, then there's three different ways we could do that. Okay, so we could draw a line here like that, and another line like that. Now, both these lines are parallel to one another, so that's one of the lines, that's another line. So they're parallel to one another, that's they get the same gradient. Now, there's another way we've drawn it out. We could have two lines that they aren't parallel to one another. Okay, so they just cross over, so they cross over something like that. Okay, now the other option that we would have is that the lines are parallel to one another, and all the lines are all the points in the line are collinear. So we draw a line like that, and then there's the other line there. So that's one of the lines there, and that's the other line. But both the lines lie along one straight line. Okay, so all the points on these lines are said to be collinear, meaning from the same line. Okay, so that's what we're interested in, is the collinear. Now, if we were given 3 points, say a point A, right, which would be some value x1, y1, and a point B, x2, y2, and a point C, which is x3, y3, and we were told these points, and we were told, asked the question is, are these 3 points collinear? So they would be collinear if we'd been able to draw a straight line through all of them. So if, say, that was a point A, and that was a point B, and that was a point C, okay, so we can draw a straight line through all of them, so these points are collinear. So the way to find out whether that's the case is you can find the gradient of this line here, MAB. So now we've got the gradient of MAB, so we can call that, well, just call it MAB, okay, and we can also look and find the gradient of the line MBC. Okay, now we know that if MAB equals MBC, that's if both the gradients are the same. So we would know that the gradients of both lines are the same. Okay, but that could mean that it could look like this, okay, where they're parallel, because both these gradients are the same. Or it could look like this, because both these lines are parallel. So both these lines are parallel and have got the same gradient. But the thing is, we know that all 3 points are collinear, because this point B is common to both of these lines. Okay, so B is common to both this line here and this line here. Therefore, the 3 points there will be collinear. Okay, now we will be going over and we'll go through some examples on the examples videos. Okay, so we can leave that there for now. And we'll look at the second thing there that we were going to do in this video, was looking at the gradient of a line and thinking about it as the tangent of an angle. So we could draw a line out like that, and we could draw a line there. Okay, so if we call that our y axis, that's our x axis, then we know that the gradient of the line is this distance here, we can call delta y, divided by this distance here is delta x. But we already know from trigonometry that the tangent of this angle here is equal to delta y upon delta x. So you could say tan of theta equals delta y upon delta x, which actually equals the gradient. Okay, so we can think of the gradient here as the tangent that the angle makes here, okay, with the positive x direction. Okay, so you could draw that straight down like that, you can continue it down there, and that angle there is the same as that angle there. Okay, so the gradient of a line M is equal to the tangent of it's equal to the tangent of the angle that the line makes with the x-axis. Okay, so again, we'll go over these when we go over the in example videos. Okay, so thank you for listening, and goodbye.